A block of ice wandering through the space between the stars is carrying within it a type of water that is 30 times denser than the water in our solar system, a type of water so ancient that it formed before our sun was even born. And no one expected that a tiny fragment flying by in just 65 days could carry a story older than the Earth, the Sun, and the entire solar system combined. Stay with me, because I am about to take you through what scientists from NASA, ESA, and JAXA have just confirmed about 3I/Atlas. And hit subscribe right now, because this channel analyzes real space discoveries without any hype. And you do not want to miss what else is emerging from the space between the stars. On the 1st of July, 2025, the Atlas station in Rio Hurtado in the middle of the Chilean desert detected a bright dot moving unusually, and in just a few days, the hyperbolic orbit was confirmed with an eccentricity of 6.14, a record-breaking number and undeniable proof that this object came from outside the solar system. This is the third interstellar object humanity has ever seen, after Oumuamua in 2017 and Borisov in 2019. Initially, the astronomy community framed it as just another interstellar comet, less mysterious than Oumuamua, similar to Borisov. But by the 6th of August, the James Webb telescope captured its first image, and an unusual sign emerged. The coma of 3I/Atlas was dominated by carbon dioxide rather than water, something very hard to believe at a distance of 3.3 astronomical units. But carbon dioxide dominance was only the prelude. On the 3rd of October 2025, when 3I/Atlas flew past Mars at a distance of only 30 million kilometers, closer than any other planet during its entire visit through the solar system, and no ground-based telescope could capture it from a favorable angle like the spacecraft hovering around Mars at exactly that moment. On that very day, the three largest space agencies in the world simultaneously turned their spacecraft in the same direction, something unprecedented in the history of space exploration. The NASA team mobilized three valuable assets. The Mars Reconnaissance Orbiter used its HiRISE camera, a camera originally designed to photograph the surface of Mars from a few hundred kilometers altitude, now forced to capture a target 30 million kilometers away. The MAVEN orbiter used its imaging ultraviolet spectrograph continuously for 10 days from the 27th of September to the 7th of October, running in a special mode to separate the comet's hydrogen from Mars's hydrogen and interplanetary hydrogen, a technique never needed before because no interstellar comet had ever come close enough to require it. And most notably, the Perseverance rover on the surface of Mars itself paused its geological survey duties to point its Mastcam Z camera up at the night sky and capture a faint dot on the 4th of October, becoming the only surface robot in history to ever stop its work to photograph an interstellar object. The ESA team contributed Mars Express, a spacecraft operating since 2003, using its HRSC camera, and the ExoMars Trace Gas Orbiter using its Cassis camera. Nick Thomas, head of the Cassis team, frankly described the difficulty of this when he said it was an extremely challenging observation for the instrument because the comet was 10,000 to 100,000 times fainter than surface targets on Mars. The CNSA team contributed Tianwen-1 with its HiRIC camera, preparing from early September by running simulations, calculating orbits, and testing the equipment multiple times in succession because the relative speed between 3I/Atlas and the spacecraft was 86 kilometers per second, meaning even 1 second of delay and the target would fly out of the frame. Pause for a moment to feel what is happening here. These cameras were designed for a completely different job, photographing the surface of Mars a few hundred kilometers below, with the glaring sunlight reflecting off the red soil, yet they were forced to turn upward to the sky to catch a faint bright dot 30 million kilometers away, 10,000 to 100,000 times fainter than their original mission, and all the science teams knew they had only one window of a few minutes to capture it. But the three agencies at Mars were only the opening act of an even longer observation campaign. On the 6th of November 2025, NASA's Europa Clipper, the spacecraft on its way to Jupiter to study the icy moon Europa, activated its Europa ultraviolet spectrograph built by the Southwest Research Institute and observed 3I/Atlas for 7 straight hours from a distance of 164 million kilometers. Kurt Rutherford, head of the Europa UVS team, admitted that the chance to observe another scientific target on the way to Jupiter was completely outside their original plan. The instrument detected oxygen, hydrogen, and dust in the comet's coma. Then from the 26th to the 28th of November 2025, JAXA's JIRSM, Japan's X-ray Space Observatory, conducted a 17-hour target of opportunity campaign, and this was the first time any interstellar object in history was imaged in X-rays. The soft X-ray telescope X-TEND captured an X-ray halo spreading 400,000 kilometers around the comet's nucleus, repositioned 14 times over 3 days to keep the target within view. The physical mechanism behind this X-ray image is charge exchange, when solar wind ions fly through the gas around the comet and exchange electrons with them, emitting characteristic X-rays of carbon, nitrogen, and oxygen. 7 days later, on the 3rd of December 2025, ESA's XMM Newton independently confirmed the result with 20 hours of observation using its most sensitive EPIC PN camera. But there was another spacecraft in the most special position in the entire fleet, closer to 3I/Atlas than any other human asset at the exact moment of perihelion, that activated all 5 of its scientific instruments, captured 11 gigabits of data, but for technical reasons, that precious data block was stuck in deep space for 3 straight months, unable to transmit back to Earth. We will come back to it at the end of the video, because what it saw answered the final and biggest question in the entire story of 3I/Atlas. Before 3I/Atlas, no object had ever caused the 3 largest space agencies in the world to simultaneously adjust their scientific missions. No interstellar object had ever been imaged in X-rays. This was the first time in human history that an entire planetary fleet turned its head toward a single bright point, and all 3 teams knew they had only one window of a few minutes to capture it before it disappeared forever. But the most important moment in the entire visit, the perihelion moment when 3I/Atlas came closest to the Sun, was the moment no one on Earth could observe directly. In the darkness behind the Sun, a second anomaly was happening. An anomaly big enough that a leading astronomer at Harvard had to publicly ask a question that the entire scientific community then had to verify with 3 radio telescopes on 3 continents. On the 29th of October 2025, 3I/Atlas reached perihelion, the moment it came closest to the Sun during its entire visit, at a distance of 1.36 astronomical units, equivalent to 203 million kilometers. But it had slipped behind the Sun from mid-October, disappearing from all ground-based telescopes and space telescopes near Earth. Perihelion is the most important moment in the entire visit, the moment when the Sun's heat impacts the surface most strongly, when physical and chemical reactions peak, but it is also the moment no one on or near Earth could observe directly. In that darkness behind the Sun, an anomaly was detected, not by a new image, not by a new spectrum, but by radar and by position measurements accurate to thousandths of an arcsecond. David Farnokia, a trajectory engineer at NASA's Jet Propulsion Laboratory in Pasadena, whose daily job is to calculate orbits of solar system objects with the highest precision humans can achieve, synthesize data from the Atacama Large Millimeter Array in the Chilean desert, along with other ground-based observatories that had caught 3I/Atlas before and after the time it disappeared behind the Sun. The result made him check his calculations multiple times. 3I/Atlas deviated 4 arcseconds from the position that the gravity of the Sun and planets should have taken it to. The more specific number is a non-gravitational acceleration directed away from the Sun, about 135 kilometers per day squared in the radial direction, detected at a statistical significance of 3.7 sigma. In other words, something is pushing 3I/Atlas away from the Sun, not gravity, not ordinary solar radiation, but something else hidden inside or beneath the surface of the ice block. If it were sublimation of gas like ordinary solar system comets, strict momentum calculations show that 3I/Atlas would need to lose about 1/6 of its total mass in exactly that month around perihelion to produce that acceleration. That is an enormous amount, so enormous that if true, the weight and internal structure of 3I/Atlas must be very different from any comet humans have studied before. In that context, Avi Loeb, astronomy professor at Harvard University and founder of the Galileo Project, publicly asked a question on the 30th of October 2025, just one day after perihelion. Could this thrust come from a source other than natural sublimation? He did not claim it was extraterrestrial technology. He carefully posed a verifiable question and asked the scientific community to verify it with the best instruments humans have. And what happened next is how science responds most correctly when faced with a fringe but verifiable question. It verifies instead of ignoring it. The SETI Institute led the campaign. The research team led by Sophia Sheik used the Allen Telescope Array at Hat Creek Radio Observatory in California, a network of 42 radio dishes operating in parallel, scanning the 1 to 9 gigahertz band for 7 hours 15 minutes continuously. The result was 74 million distinct narrowband signals detected, filtered by the BLISS software system down to 2 million noteworthy signals, then further filtered to 211 signals needing detailed investigation, and finally through direct visual inspection by human researchers, none of those signals were confirmed as artificial. The upper limit on any transmitter power, if it existed on or inside 3I/Atlas, was set at 10 to 110 watts. In parallel, the Breakthrough Listen program used the 100-meter Green Bank telescope in West Virginia on the 18th of December 2025 to scan the 1 to 12 gigahertz band, pushing the detection limit down to 100 milliwatts, smaller than the power of the cell phone you are holding in your hand. And the BLUES program used Meerkat in South Africa to scan the 900 to 1,670 megahertz band, pushing the detection limit down to 17% of a watt. 3 radio telescopes on 3 different continents, North America, Africa, and analysis centers in Berkeley, reached the same clear and unambiguous conclusion: no artificial signals were emitted from 3I/Atlas at any detectable power level. This is a natural object. But the very fact that humanity had to use an entire 3-continent system to double-check is evidence of the importance of this moment. This was the most detailed targeted SETI campaign in the entire history of the field, and the answer was clean. So what is the real answer to that strange non-gravitational acceleration? On the 15th of January 2026, NASA JPL Horizons officially updated the orbital model of 3I/Atlas. The non-gravitational acceleration fits strong carbon dioxide sublimation, not water sublimation like most other solar system comets. The carbon dioxide to water ratio in the coma of 3I/Atlas, measured by the James Webb telescope, was 7.6 times, an unusually high ratio that forced researchers to check the measurement history of every solar system comet for comparison. It was precisely that unusually dominant carbon dioxide, sublimating much more strongly than water at the same solar distance, that was enough to push 3I/Atlas off its orbit with the acceleration Farnokia measured. And when researchers recalculated the comet nucleus size after understanding this strong carbon dioxide activity, the final number obtained was much smaller than the initial estimate from Hubble, only about 520 to 748 meters, instead of a figure that could reach 5.6 kilometers in the initial estimate before knowing the role of carbon dioxide. One paradox solved by pointing out another paradox. The unusually dominant carbon dioxide explains why 3I/Atlas was pushed harder than ordinary comets. But that only pushes the question one level deeper. Why did 3I/Atlas contain so much carbon dioxide in the first place? Carbon dioxide freezes at extremely low temperatures, much lower than water, so low that for carbon dioxide to remain stable in the nucleus, this ice block must have formed in an environment colder than most of what humans have ever touched. That question can only be answered by looking inside the ice block, reading the composition of the inner layers rather than the weathered outer shell after billions of years flying through the space between the stars. And there is only one way to look inside a comet without landing on it: wait for it to undress itself in front of the sun. Every comet carries on itself an old coat, a surface ice layer that has been transformed by cosmic radiation and solar ultraviolet rays over millions or billions of years of slow flight through the space between the stars. This coat does not reflect the primitive composition of the comet. It is only the weathered shell after the long journey, battered by every ray of radiation that the space between the stars throws at it. When the comet approaches the sun and is heated for the first time after billions of years of cold, it is precisely this old coat that is burned first, sublimates first, disappears first, and only when the old layer has been eroded thin enough does the primitive ice layer underneath begin to be exposed, carrying the chemical composition from the time the comet first formed, preserved intact through billions of years under the protection of the outer shell. For 3I/Atlas, that coat may have wrapped its nucleus for many billions of years flying across the Milky Way, and evidence for that shedding was gradually revealed right after perihelion. On the 15th and 16th of December 2025, when 3I/Atlas had re-emerged from behind the Sun and was at a distance of 329 million kilometers, the James Webb telescope used its mid-infrared instrument to perform the first observation after perihelion. On the 27th of December, the team performed the second observation when the object had moved out to 379 million kilometers. Matthew Bilyakov, a graduate student at the California Institute of Technology, led the analysis of the results. What was obtained made the entire team check it multiple times. Methane appeared for the first time in the entire visit. Before perihelion, methane was completely undetected despite their very careful search. After perihelion, methane was clearly emitted, and the amount of methane relative to water was surprisingly high, a ratio that few solar system comets can match. 3I/Atlas was shedding its coat in front of the sun. The old coat was burned off layer by layer, and the primitive layer underneath began to spew gas outward for the first time perhaps in billions of years, and possibly also the only time in the entire life cycle of this ice block, when its primitive composition was seen directly by some scientific instrument. Independent evidence for this shedding came from other groups. HUTC makers and collaborators measured the nickel-to-iron ratio in the coma of 3I/Atlas, and found this ratio going from an extremely unusual level down to a normal level as the object approached perihelion. What does that mean? It means the old surface composition with distinct characteristics was gradually eroded to reveal a more normal inner composition, like peeling an old paint layer to reveal the original wood underneath. Rahad Gankar and collaborators, observing with the Very Large Telescope of ESO in Chile, independently confirmed this result in a paper published in the Astrophysical Journal Letters, volume 995, L34. And NASA SphereX, A space telescope specialized in infrared spectroscopy reobserved 3I/Atlas in December 2025 after its first observation in August and recorded something astonishing. The H2O gas signal was 20 times brighter than in August. The characteristic absorption spectrum of H2O ice on the surface had disappeared, replaced by thermal emission from organic silicate dust particles. The third independent evidence for the same story: the shell had peeled, the inner gas was spewing out. But all of this was still only indirect evidence of the shedding. The bigger question, the real question, still hung in the air. What is the true inner layer composition? That question could only be answered by directly measuring the isotopes of the elements in the inner layer, a level of detail that until before 3I/Atlas, no interstellar object had ever been bright enough to measure. Oumuamua was too faint, Borisov was too far, and also too faint. 3I/Atlas was the first time in human history there was a chance to measure the isotopes of a sample from outside the solar system, and the leader of that effort was Martin Cordner, a cosmochemist at NASA Goddard Space Flight Center in Greenbelt, Maryland. His team used the near-infrared spectrograph of the James Webb Telescope combined with the Atacama Large Millimeter Array in Chile to directly measure isotopes in the water spewing from 3I/Atlas during those shedding weeks. The result was published in the journal Nature on the 22nd of June 2026 with DOI 10.1038/S415860261077716, and the number was right in the first line of the results section, the D/H ratio. That is, the ratio between deuterium and hydrogen in the water of 3I/Atlas was 0.98%, plus or minus 0.06. To understand what this number means, compare. Water in solar system comets has D/H around 0.02 to 0.05%. Earth's seawater has D/H around 0.016%. 3I/Atlas water was about 30 times higher. This is a number never seen anywhere in the entire solar system. Not slightly different, not noteworthy, completely different. The physical meaning behind this number is very direct. Deuterium accumulates preferentially when water forms at extremely low temperatures, because at those temperatures, chemical reactions distinguish between ordinary hydrogen and deuterium more favorably. The 0.98% number indicates that the water in 3I/Atlas formed at a temperature lower than or equal to 30 Kelvin, equivalent to minus 243 degrees Celsius, an environment colder than most pre-solar molecular clouds that humans have ever mapped. The water in 3I/Atlas is not solar system water, not nearly the same, not slightly off. It is completely different, 30 times denser chemically than anything humans have ever touched. And we could only measure it because 3I/Atlas undressed itself in front of the sun during the final 6 weeks of the visit, eroding the old shell thin enough to reveal the inner water for the first time, perhaps in billions of years. If 3I/Atlas had flown 30% farther, 30% faster, or simply never got close enough to the sun for the coat to be burned, we would never have known what kind of water it contained inside. But if you think methane emerging at perihelion and water 30 times denser was strange, there was another phenomenon that started 3 months before perihelion, a phenomenon that should not exist according to any comet physics laws that humans have known. On the 21st of July 2025, the Hubble telescope captured an image that made astronomers check their equipment 3 times. Every comet in the solar system has a tail pointing away from the sun. The reason is very simple and has no known exceptions before 3I/Atlas, the solar wind, that is the stream of charged particles continuously escaping from the star's surface, combined with radiation pressure created by the sun's photons themselves. Both push gas and dust particles from the comet's coma in the direction opposite the sun. One can draw the tail of any comet on paper just by knowing the sun's position and the comet's position at that moment, and that is what astronomers teach first-year students in the very first basic lecture on comets. That was also the rule that 3I/Atlas broke. On the 21st of July 2025, when 3I/Atlas was still at a distance of 3.8 astronomical units from the Sun, more than 3 months before perihelion, and still just a fairly faint bright dot, David Jewett at the University of California in Los Angeles and his team used the Hubble telescope to capture a series of high-resolution images. What they saw in the frame made them check the equipment 3 times and finally include it in the published paper, along with all the exclusions of possible errors. The image showed a teardrop-shaped structure extending from the nucleus of 3I/Atlas outward, but not pointing away from the sun like every normal comet. It pointed straight toward the sun. The length of this unusual structure was about 60,000 kilometers, with an elongation ratio of 2 to 1 in the observed sky plane. This was something that should not exist. Jewett's team immediately ruled out the possibility that this was an optical perspective effect tricking them, that is, a normal tail appearing reversed due to the viewing angle. Earth's line of sight at that time was only 10 degrees off the Sun 3I/Atlas axis, and with this 10-degree angle, three-dimensional geometry allowed precise calculation of the true length of the structure in three-dimensional space rather than just in the image plane. The calculation results did not change the conclusion. This was a real physical structure pointing toward the Sun in three-dimensional space, not a viewing angle illusion. Independent confirmation immediately came from several other research groups in the same year, 2025. The Bolin and Collaborators Group, the Chandler and Collaborators Group, the Seligman and Collaborators Group, the Tonry and Collaborators Group. None denied it. By the 30th of November 2025, and continuing on the 7th of January 2026, Hubble reimaged 3I/Atlas after the object had passed perihelion and was on its way out, and the anti-tail was still there, pointing toward the Sun like an arrow. Not a temporary effect of perihelion, not a fleeting odd phase. It was a persistent feature of this ice block. So how could it exist? The answer came from a peer-reviewed paper published in the monthly notices of the Royal Astronomical Society in 2025, providing a detailed physical explanation. The coma of 3I/Atlas was not an ordinary gas cloud like the coma of other solar system comets. It was a jet-like flow of solid H2O ice particles pushed out from the nucleus by gas drag when carbon dioxide sublimated strongly from inside. These solid H2O ice particles were heavy enough not to be pushed far by solar radiation pressure like ordinary fine dust particles. Instead of being pushed backward, they moved relatively slowly in the exact initial direction that the gas drag had pushed them, creating a structure that looked like a tail pointing back toward the Sun. It was precisely the dominant carbon dioxide that caused this phenomenon, not water like in ordinary comets. But pay attention to what is happening here, because this is the moment the story lights up. 4 separate paradoxes of 3I/Atlas that we just went through in 4 different windows. An orbit pushed off course that the gravity of the entire solar system could not explain, a primitive ice layer self-revealed by undressing in front of the Sun, a type of water 30 times denser than anything in our solar system, and a tail growing against the most basic physics rule recorded by 4 completely different methods, at 4 different times, by 4 completely independent research groups in 4 different laboratories around the world. But when putting all 4 together and looking from above, those 4 paradoxes point to the same single story. All 4 phenomena are direct consequences of one single truth. 3I/Atlas contains an unusually large amount of carbon dioxide because it formed at extremely low temperatures, low enough that carbon dioxide, a substance that only freezes at minus 78 degrees Celsius and usually only exists in trace amounts in ordinary comets, exists in the nucleus of 3I/Atlas at a ratio dominating even water. When 3I/Atlas approached the Sun, this carbon dioxide sublimated much more strongly than water sublimates at the same solar distance. It was precisely this dominant carbon dioxide sublimation that pushed 3I/Atlas away from the Sun with the non-gravitational acceleration that Farnakia measured in Section 2. It was precisely this dominant carbon dioxide sublimation that eroded the old coat strongly enough to reveal the primitive inner layer, allowing Belyakov and Cordner to measure methane and D/H in Section 3. It was precisely this dominant carbon dioxide sublimation that pushed the H2O ice particles into the tail pointing back toward the Sun that Jewett captured in Section 4. And all those traces were revealed because the water inside 3I/Atlas formed at temperatures below 30 Kelvin, the strongest evidence being the 0.98% D/H number in the Nature paper. 4 separate fingerprints, an orbit pushed off course that no one could explain immediately, an inner ice layer revealed by self-undressing, a tail growing against physics rules, and a type of water 30 times denser than anything in our solar system. All point to the same common story. 3I/Atlas was strange in 4 different ways at the same time, but for the same single reason. And the final question, the real question is, what is the root cause behind that same single reason? What kind of object could form at temperatures below 30 Kelvin, that is minus 243 degrees Celsius? In what environment in the universe can it be that cold? How far away from us, and how long ago? The answer to that question did not come from Earth. It did not come from Mars. It came from a spacecraft that was already in the right position in the middle of the solar system throughout the perihelion time, with a hard drive containing precious data stuck in deep space for 3 straight months, unable to transmit back to Earth, waiting for humanity to be patient enough to listen to the story. That spacecraft is JUICE, short for Jupiter Icy Moons Explorer, a mission of the European Space Agency ESA that is on its way to the Jupiter system. On November 2nd, 2025, just 4 days after the perihelion of 3I over Atlas, JUICE was at a distance of 66 million kilometers from the interstellar ice chunk, closer than any other spacecraft at exactly the moment of its highest activity. The mission operations team turned on all 5 scientific instruments at once: JANUS, MAGIS, UVS, SWI, and PEP. But there was one technical obstacle that delayed the entire precious dataset by 3 months. At such close distance to the Sun, JUICE had to use the main high-gain antenna as a heat shield to protect sensitive equipment. Only the secondary medium-gain antenna could transmit data back to Earth at a slow pace. 126 scientific files containing 11.18 gigabits of data had to wait across hundreds of millions of kilometers. The final data arrived on Earth from February 18th to 20th, 2026. The results from Mayo made the whole team double-check. 3I over Atlas was ejecting 2,000 kilograms of water per second, equivalent to 70 Olympic swimming pools every day. The Janus camera captured a bright coma along with 2 clear tails, 1 plasma tail and 1 dust tail. But JUICE's truly major contribution lies in the same Nature paper on June 22, 2026, when the same research group that measured the D over H and 3I over Atlas also published a second result with even deeper implications, the isotope of carbon. The ratio of 12C over 13C is an extremely sensitive fingerprint of age in astrochemistry. 13C is produced by nucleosynthesis in previous generations of stars, and the older the Milky Way is, the more 13C accumulates. An environment poor in 13C, meaning a high ratio, indicates that the object formed in a still young Milky Way. The measurement result in 3I over Atlas. The ratio of 12C over 13C from 141 to 191 for carbon dioxide, and from 123 to 172 for carbon monoxide. Both far exceed every solar system comet ever measured, and even exceed the interstellar molecular clouds closest to us. Independent confirmation came from the group led by Cyrielle Opiton, an astronomer at the University of Edinburgh in Scotland. Her team used the UV visual Echelle spectrograph on the Very Large Telescope of ESO in Chile for observations in December 2025. The result in Nature Astronomy: the carbon and nitrogen isotopes in cyanide CN are consistent with formation in the outer disk of an old metal-poor star. When combining D over H, 12C over 13C, and the orbital dynamics analyzed by Hopkins and colleagues in 2025, the Milky Way chemical evolution models give 3I over Atlas an age from 10 to 12 billion years. The strongest comparison number, the Sun is only 4.6 billion years old. 3I over Atlas could be 5 to 7 billion years older than the Sun. Its kinematic origin traces back to the thick disk of the Milky Way, the region containing the oldest stars, formed during the cosmic noon period about 10 to 13 billion years ago. Before 3I over Atlas, everything humanity knew about cosmic noon came from observing the light of galaxies billions of light years away with no physical sample we could hold in our hands. Now we have a real piece of ice, with real measured isotopes from exactly that era. It is like finding an unopened bottle of wine from ancient Egypt. When the Sun did not yet exist, when Earth had not yet formed, this ice chunk was already floating around another star in the thick disk of the Milky Way. A star that may have long since gone out, turned into a black hole, a neutron star, or a cold white dwarf. A planetary system that may have been completely destroyed. 3I over Atlas did not come from a star. It came from an era, and that star may no longer be there. At the exact moment this video is airing, where is 3I over Atlas? On March 16, 2026, it had flown past Jupiter, and in July 2026, it just crossed the orbit of Saturn. It will cross Uranus in April 2027 and Neptune in April 2028, then fly forever into interstellar space. No space mission can catch up. But there is light at the end of the tunnel. ESA is building Comet Interceptor, scheduled for launch in 2029, the first spacecraft designed to park at a Lagrange point and wait for the next interstellar object. The Vera the 100th. Rubin Observatory in Chile has just begun its legacy survey, expected to discover a new interstellar object every few months in the coming decade. And if in just 65 days a small ice chunk could tell us the story of a planetary system that died when the Milky Way was young, then every next interstellar object is also carrying a similar story, waiting for us to be humble enough to listen. Subscribe to the channel and turn on notifications. Thank you for watching.